Okay, this should be group charge. So it's page 6 on your flip book. This is the last of the terms that we have to fill into the periodic table split book. So it's called group charge. And group charge is also known as an oxidation number. Okay, group charge is also known as an oxidation number. So I would write oxidation number somewhere on that page near group charge. And what an oxidation number is, it's just a number that tells you how many electrons an element is either going to lose to achieve stability or gain to achieve stability. Okay, that's all it tells us. So the oxidation numbers are the same throughout a group. Okay? So if you would on yours, in the transition elements, we're going to write that those oxidation numbers are varying. Okay, they're varying for the different elements, and they even vary for specific elements. For example, iron has 2 different possible oxidation numbers, iron 2 and iron 3. And lots of the other transition metals have more than one oxidation number. So when we start bonding, we'll look a little closer into those. But for now, we just want to look at the oxidation numbers for the representative elements. So those are group 1, 2, and then 13 through 18. So who remembers how many valence electrons the group 1 element has? Okay, so valence electrons. We have 1, then 2, then 3, 4, 5, 6, 7, and 8. And again, those are the valence electrons. So if we're looking at, let's say lithium here in group 1, okay, lithium. What's the magic number that it's trying to get to in order to achieve stability? 8 valence electrons. Okay, well this one is actually trying to get to. Let's look at the one beneath this one. Let's look at sodium. Okay, sodium is trying to get to 8 valence electrons. Lithium, when it is actually trying to get to 2. Anyway, sodium trying to get to 8. So it has 1 valence electron. From yesterday, what is it going to do with that valence electron? Is it going to gain 7 or is it going to lose the 1? It's going to lose 1. It's going to lose 1. So it had, to begin with, it had 11 valence electrons. When it loses 1, how many does it have left over? 10. So what does that give it as far as its overall charge? Positive. It gives it a 1 positive charge. All of the elements in group 1 have a 1 positive charge, or 1 positive is their oxidation number. Okay, 1 positive is their oxidation number. And on these oxidation numbers, you can either write the number first and then the positive, you can write the positive and then the number, or if it's singular, you can just write positive. You will see these in books and worksheets and stuff like that in all of these forms. And the same goes for the negatives. It can be a 1 negative, negative 1, or just negative. All right, so the second group has 2 valence electrons. So what is it going to do, or what are they going to do in order to achieve stability? They're going to kick 2 of them off. So what would that make their oxidation number? 2 positive. Excellent. And you can fill these in the boxes like I'm doing, or if you want to just draw an arrow that shows all of them in a group of 2 positive, that's fine as well. The group 13 elements that start with boron, they have 3 valence electrons. So they have space for 5, or they could kick off the 3. What are they going to do? They're going to kick off the 3, so what were their oxidation numbers? Excellent. So the elements here, where group 14 are, they can either be for positive or they can be for negative. They can be either or. But typically these things form covalent bonds, which are sharing. They're not actually exchanging electrons, right? So we don't really consider them when we're looking at ionic bonding or the actual exchange of electrons. So you can write either for positive or for negative, but for the most part, you wouldn't write 0, because that's not true, but you can just maybe write an X or something like that if you ever came across a question that's that. So the group 15 elements with 5 valence electrons, what are they going to do to achieve that magical number of 8? They're going to gain 3. So what would that make their overall charge? Right, it's going to be 3 negative because they have 3 more electrons than they have protons. So that gives it an overall charge of -3 or 3 negative. Group 16 has 6 valence electrons, so its charge will be 2 negative. They need to gain 2 electrons in order to achieve a stable electron or outer orbital that has 8 electrons. And what about the halogens? Yeah, they have 7 valence electrons, so they only need to gain 1 in order to achieve stability. What are the noble gases going to do to achieve stability? They're already stable, so their oxidation number is 0. And that's group charge. Ta-da! Ta-da!